So limiting reactant problems are special types of stoichiometry problems. These are going to be problems where you're given amounts of multiple reactants and asked to figure out the amount of product produced, perhaps the amount of excess reagent that is left over, or even how much of the limiting reactant you would need to combine with all of the excess reagent. So what we're going to do is first try to organize the wording in this by putting the amounts underneath each of the substances in the balanced equation. So we've got 2.00 grams of the hydrogen. We have 100 milliliters of the nitrogen gas, and it's at STP, which of course will be important in terms of converting between volume and moles. They want us to figure out the mass of any substances that are left in the container. Well, obviously, the product is going to be left over in the container, and whichever reactant is in excess will be left over in the container as well. So what I have to do at this point now is just choose one of the reactants and figure out how much of the other reactant I need so I can determine my limiting reactant. So I'm going to go ahead and choose the nitrogen to start with. So I've got 100 milliliters of the nitrogen gas. And what I want to do is go through a series of dimensional analysis conversions to figure out how much hydrogen I would need to react with all of that nitrogen. So first I would convert the 1,000 milliliters of nitrogen to liters of nitrogen. And the reason we're doing that is so that we can go from liters of nitrogen to moles of nitrogen. Now that I'm at moles of nitrogen, I can use my mole bridge, use the equation. And from the coefficients, I know that for every 1 mole of nitrogen molecules, I need 3 moles of hydrogen molecules. Okay, again, from the balanced equation. And once I'm in moles of hydrogen, I can go to 1 mole of hydrogen has a mass of 2.02 grams of hydrogen. All right, and then I can go ahead and calculate this. And I get 0.0271 grams of hydrogen, and again, that one little word that's going to help us with our thinking here is needed. Okay, so the stoichiometry part, we'll go back through and make sure our units all canceled out. The stoichiometry part should be getting pretty familiar with us, familiar for us. It's this question of what do we do with that number now that we need to do a little bit of thinking about. Well, that's how much hydrogen would be needed to react with all the nitrogen gases present. Well, if we look at how much we have, right, here's the amount of hydrogen we have, this is 2.0 grams, we realize that we have quite a bit of extra hydrogen gas. So I can go ahead underneath this and do that calculation to show that if I take my 2.00 grams of hydrogen that I have, and I subtract the 0.0271 grams that are needed to react, I end up with 1.97 grams of hydrogen left over. And of course, there would be 0 grams of the N2 as it is the limiting reactant. Okay, so there's the first part of our solution there, is the amount of each of the reactants that's left over. So 0 grams of my limiting reactant, and then I would have 1.97 grams of the hydrogen left over. The next question is, how much of the ammonia am I going to produce? Well, now we go back to just doing a regular stoichiometry problem, but again, we need to do a little bit of thinking here. Which reactant is going to determine how much ammonia I can produce? Well, it's not going to be the excess reagent, right? So it's not going to be the H2. It's going to be the nitrogen. It's a limiting reactant. So we're going to go back and start with that one again. So we've got the 100 milliliters of the N2 over 1, 1,000 milliliters to 1 liter, 22.4 liters of N2 to 1 mole of N2. We look at our balanced equation, and for every 1 mole of the N2, I will produce 2 moles of the NH3. And for every 1 mole of NH3, there'll be 17 grams of NH3. And we have 0.152 grams of NH3 produced. So now we have the final piece of our solution here, which is the mass of the NH3 produced. So again, to go back through, what we did here was we chose one of the reactants, and we figured out how much of the other reactant we would need. The analysis of the amount we need and the amount we have tells us what our limiting reactant is. So we realize that we have excess of the hydrogen, which means that nitrogen must be the limiting reactant. And then we did a little calculation to figure out the amount of hydrogen that was left over. We came down, we used our limiting reactants. Right, that's important here. You use your limiting reactant to then figure out the mass of the product that is formed. Now, the question would come up is, well, what if we had chosen the hydrogen to start with at the beginning? So let me show you what that calculation would look like. All right, so here I've gone through and done the calculation for us. So starting with our grams of hydrogen, we go from grams of hydrogen to moles of hydrogen to moles of nitrogen. Now, our nitrogen is given to us in volume at STP, so we don't want to go to grams of nitrogen, so we're going to go from moles of nitrogen to liters of nitrogen, liters to milliliters, so we can compare. So now we look at that number, and we've got we've calculated that we need 7,400 milliliters of nitrogen. Well, remember back in the problem, we only have 100 milliliters of nitrogen. So again, we do a little bit of thinking here and realize, oh, well, gee, we don't have nearly enough nitrogen, so nitrogen must be the limiting reactant. So regardless of which one you chose to start with, you would be able to determine what the limiting reactant is. The difference is that if you got to this point here and you figure out, oh, the nitrogen is the limiting reactant, you could go back and go ahead and do you could do this calculation to figure out how much of the ammonia is produced, but you would have to go back and do the conversion from nitrogen to hydrogen needed to figure out how much hydrogen was left over. So really, it's just a matter of doing a bunch of stoichiometry problems, but thinking in between each one of them as to what the numbers mean. Again, it's another one of those situations where it's a pretty standard procedure. What you need to do is just go through it quite a few times until you get the hang of it and get everything worked out.